All right, section 5.1, we're going to be talking about polynomials and graphing polynomials and describing their end behavior and things of those matters. But we just need to review some of the basics for polynomials. A polynomial function it has distinguishing behaviors. You can look at its algebraic form and know something about its graph, and you can look at its graph and know something about its algebraic form. Some of these words you'll remember from Algebra 1, such as the idea of a monomial, is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So it's a single-termed polynomial. The degree of a monomial in one variable is the exponent on the variable. A polynomial is a monomial or the sum of multiple monomials. The degree of a polynomial in one variable is the greatest degree amongst the monomial terms. So this here you did in Algebra 1. And so hopefully this some of that stuff, the words start to remind you of things and things like that. So make sure that this is ringing a bell. Hopefully you start to see the connection between what you learned before and what you're learning now. A polynomial with the variable x defines a polynomial function of x. The degree of the polynomial function is the same as the degree of the polynomial. Okay, so for some of you that may just seem like a lot of words, but hopefully you start to see some of the way these problems are formed and they start to ring back to your prior knowledge from Algebra 1. All right, so the standard form of a polynomial function arranges the terms by degree in descending order, so highest degree to lowest degree. And so you should remember this from Algebra 1 as well. And so like we were talking about before, a single-termed polynomial, here's an example, maybe just the number 5, is called a monomial. A two-termed polynomial is called a binomial. A three-termed polynomial is a trinomial. And then a two-termed would be binomial again. And anything greater than 4 terms is a polynomial. But then you have this naming the degree. So the degree is termed by the exponent on your variable. So in this case, this would be a linear. This would be a quadratic because it is squared. This would be cubic, quartic, and then quintic, and so on. These names may be not so much familiar from Algebra 1, but definitely this piece here. So here it just says, write each polynomial in standard form. What is the classification of each polynomial by degree and the number of terms? So standard form just means highest degree to lowest degree, so this would be 9x squared plus 3x plus 5. Because of the 2, this is a quadratic. And because there's 3 terms, it's a quadratic trinomial. The second question, same idea, highest degree to lowest degree, so x to the 4th wins. We need to combine like terms here, so that becomes plus 4x squared, and then we've got plus 4x, and then minus 12. This is definitely a polynomial. And because of the exponent of 4, this is a quartic polynomial. All right. So the degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points, or places where the graph changes directions. It also affects the end behavior, or the direction of the graph to the far left and far right. Okay, so we're going to be looking at a lot of end behavior. So just keep in mind that's talking about the far left and far right behaviors of the graph. And here are some examples for various problems. And then you've got your turning points, and we'll talk about all of those items as well. So like here, for this one, your turning point takes place at your vertex where it changes direction. It goes from going up to going down. Here you have turning points where you're seeing it change here and then starts going up, and then it turns again, down, and then up again. So essentially these minimum maximum values here are representing your turning points. Your end behavior represents what it's doing at the left portion and the right portion of the graph. Same for these. Notice here that this is not a true turning point because it just kind of wiggles. But your end behavior, on one end it's down, the other end it's up. Here it's up, then it's down, and it has 2 turning points here and here. It's just something to keep in mind. So if your leading term is a x to the nth power, when a is positive, and in this case n is even, it's going to be up and up. When n is odd, it's going to be down and up. Here, if your a value is negative, it's going to be down and down. If it's an odd, it's going to be up and down. Just something to keep in mind. That is the worst star I have ever drawn, so that is even worse. Ooh, that's much better. Okay, so let's look at this together. We've got, consider the cubic function y equals 1/2 x to the third, or x cubed. What is the graph of the function? Describe the graph including in behavior, turning points, and increasing and decreasing intervals. All right, so the first thing I'm going to do is we're just going to make an XY chart, and so we're going to make XY charts, X, Y. And to do your XY chart, two options. Graphing calculator, but you also need to know how to do this by hand without the graphing calculator for the most part, or at least without the graphing calculator yet. So let's say our X values, I'm going to choose -3, -2, -1, 0, 1, 2, and a 3. And in this case, when I do this, I can either use the graphing calculator to figure out the values for this, or I know that if I'm plugging in -3 in for x here, the result is going to be -13.5. If I plug in -2, the result is -4. If I plug in -1, it's -0.5. Plug in 0, it's just 0. Then 1.5, and then 2 is 4, and then 3 is 13.5. All right, and so I can sketch this graph. All right, so in this case, sketching the graph, trying to make it look as nice as possible. It says sketch, so it doesn't have to be perfect, but it should be pretty good. All right, so we've got, oh, missed because I'm a terrible drawer, but hey, there we go. All right, so that's our graph. And so in this case, our end behavior we can get from the graph. And it's going to be, in this case, down and up. But if you remember a second ago, without the graph, we talked about this from the previous slide, that our a value in this case is positive, but our n value, or our degree here, is an odd number, so it's going to be down and then up. I just like drawing the arrows. And then it asks us to find our turning points. And so for this, we're looking for our values. All right. So for this one, there are actually no actual turning points. There are no max or min values. This is actually just a kind of a smooth curve. It turns, but there are no true turning points where it changes the way it's increasing or decreasing. In this case, it's all increasing. So there are no turning points here. And this is, what are the intervals where the graph is increasing or decreasing? Well, in this case, it's only increasing, since there are no true turning points here where it changes direction. And in this case, it's increasing from -infinity to infinity. So for all of the real numbers in this problem, it's increasing. All right, here we're looking at a second example. Same idea. It says y equals 3x minus x cubed. We can change that if we want to -3x, or -x cubed plus 3x. I like this better. So we want to make an xy table. So xy, that looks like a 4. I'm going to erase that because I can't, my handwriting's not great there. There we go, xy. And so I'm going to go -3, -2, -1, 0, 1, 2, and 3. And same idea here, we can use the graphing calculator to get the table of values, or we can do this by plugging in the x values and getting them out that way. So if we plug in -3 for x, we should get 18 back out. If you plug in -2 to this equation, you should get 2 back out. If you plug in -1, you get -2. If you plug in 0, you get 0. If you plug in 1, you get 2. If you plug in 2, you get -2. If you plug in 3, you get negative 18. So now we just need to sketch our graph. So at negative 3, it's up at 18, too far to graph. I'm not going to graph, it's too far up to graph, but negative 2, we're at 2, so that's good. And then at negative 1, we're at negative 2, so we're down here. At 0, 0, 1, 2, and then 2, negative 2, and then 3, 18. So we can just kind of put a dot way up here so we know we're going there. So in this case, this graph goes down like this, changes directions, goes back up, and then goes back down again. And so here we can clearly see that there are some turning points or some change of directions. So in this case, we're describing the end behavior. Well, in this case, we are up to start with on the left half here, and then we are down on the right half. All right. From there, it asks us to find the turning points. And so what we want to actually do for this is we're going to use this equation. So we're going to take y equals negative x cubed plus 3x. And we're going to throw this in our graphing calculator under the y1 value. And we're going to look for our calculators. We're going to allow the calculator to find the min and max values. And so ideally, this would be a min value you're trying to find, and this is the max value you're trying to find. So if you use your graphing calculator, and at this point, we've done enough of this that hopefully you remember how to do this. The calculator, let's say we calculate the max, it's going to tell you that your max for this particular piece here, where this is one of our turning points, is just going to be 1, 2. So we have a max at 1, 2, and that's a turning point. And then if we calculate the min, and we're trying to find this piece here, the calculator should tell us that that point is negative 1, negative 2. So these are our turning points. And it says, what are the intervals to where this graph is increasing and decreasing? So if you think about it logically, this graph is decreasing here, but then it switches to increasing here, and then it's decreasing again here. So the only part that it's actually increasing is that small portion there between the two min and max values. So it's increasing from essentially negative 1 for x to 1 for x. So it's increasing from negative 1 to 1, which means everywhere else it's decreasing. So that means it's decreasing from negative infinity to negative 1. And then we use this symbol to show that it's then going to pick it up on the other side from 1 to infinity. So this is interval notation. So it's increasing from negative 1 to 1 and decreasing from negative infinity to negative 1 and then 1 to infinity.